make a little bit more sense. Again, try to do this in radians. I work with radians because that's what precalc works in. If you struggle with this, think degrees for a little bit. Get yourself used to radians. Get yourself used to the patterns. It will come. The easiest way to start when you do this is like this. Take that denominator and divide it into 180. That's your angle. Because last week we determined that this is the equivalent part. So pi is equal to 180 degrees. So when you do this, take the denominator, divide it into 180. That's the angle you're using. So 4 goes into 180 45 times. God bless you. When you start this, whenever you start something with the bottom number of 4, start like this. This is the 0. This is 4 pi over 4. Whatever this number is on the bottom, put it on the top, because this has to reduce to pi, right? This side is doubled, so what should this one be? 8 pi over 4. You're again going to get something that looks like this. It's going to be one of these triangles. One of those. It looks like my big red bow tie. One angle above, one angle below. None of the other, nothing else matters. Whether it's 45, 30, 60, this is what you're going to get. Now, determine where it is. All of these reference angles, and I wasn't so sure that I made that point clear, the reference angle is the angle from the terminal side to the x-axis inside this triangle. That's your reference angle. So even if well, this one's at 45, so bless you. We'll do this one, and I'll do another one and show you where the reference angle goes. Now, once you have it labeled, these are all your right triangles. This is where your side comes in. If this is a unit circle, and it didn't say, so you can label it any which way you like. If it's a unit circle, start with your 45, 45, the way you like it. 1, 1, radical 2. If I want to put this here, did you guys use a unit circle or not? You did. God bless you. So if I want this to be a unit circle, I'm going to divide this to make sure this gets to 1. There's my sides. 1 over radical 2, 1 over radical 2, 1. Make yourself an information box. And you do not have to rationalize your radicals in the denominators. You can if you want to, because I know this one is the one you're used to doing. From that, this is all 6 trig functions. Sine. And try to get used to the x over r, y over r, y over x. Try to get used to that. Again, we take SOHCAHTOA. If you can't memorize this, have a cute mnemonic for this. Oh gosh, probably like 12 years ago now. I had a kid come from Buffalo, and back then we did an FA and FB. And he came from Buffalo, and he had a cute mnemonic for this, because I tend to pronounce it wrong. I always say SOHCAHTOA. And so everybody tells me, you can't say SOHCAHTOA. I have to say SOHCAHTOA. So he says, some old hippie caught another hippie tripping on acid. It's from the hippie days. My generation. I never took acid, but that's the mnemonic for this. So if you have any trouble memorizing that, those things always stick in your head. So now, sine is y over r. Cosine, x over r. Tangent, y over x. Remember we said A and O, x and y. This is the key right there. The h is always the hypotenuse. That's the radius. That's the r. Okay? And then the rest you fill in. So sine, y over r. All you have to do now is just go to this box. This is it. Don't even go reference your triangle anymore. Just come to this box. I call this my reference box. I tend not to put my minuses on my chart, because I kind of feel every distance is a positive distance. Plus, when we flip this around, you'll see why it kind of makes sense not to. I put my positives and negatives down in my reference box. And then from there, I build my 6 functions. Anything, remember what we said, because it's over 1, that the sine actually becomes the y value. Cosine, and actually becomes the x value. and it makes sense. X, Y, cosine sine. Tangent is y over x. Well, it's 1 over radical 2 over 1 over radical 2, which is itself, is 1. Reciprocal. That's why not rationalizing this is so much nicer for you guys. Remember, this starts with the other letter. So what's the word that starts with the other letter? Cosecant. Good. Just flip that over. Leave me radical 2. Secant. And when this one flips over, it is still a 1. So those are your 6 trig functions. Yes. Well, there was only like 6 on here, right? There wasn't very many. Just so that you get used to doing this. Now, if I had another angle, this angle, and you would see this one wasn't much work for it at all, I'm going the negative of this. So I'm starting down here, and I'm going this way, clockwise. What quadrant do I land up in? The first, because if this is 8, aren't I 1 before that? Go backwards in your thinking now. So I'm going this way. Isn't this the same angle? Right? So isn't this the same information for both of those? So same as the first quadrant. Does everybody see this negative part? You're going clockwise in the opposite direction. You're still going 4 over 4. You're getting to 8. It's 1 more before 8. It's 7. Oh, same triangle. Same information. So I label my triangle, set this up, and I've got them all. Let's do this one. I know it's not there, but let's do this one. Where would I find 5 pi over 4? Third. Because they come all the way around. This is my reference point. 4. One before it would be 3 pi over 4. One after it would be 5 pi over 4. Let me convert this, because I don't think you actually believe me. So let me convert this. So if I convert this, this goes in here 45 times. Times 5 is 225. So isn't this 180, 225? Doesn't this still give me a 45-degree reference angle? I'm still my pi over 4 as a reference angle. So my triangle, isn't it the same exact triangle? The triangle itself, same exact. So I label 1 over radical 2, 1 over radical 2, 1. I make my information box. Everything's going to look exactly the same, except my signs, my SIGNs. In quadrant 3 down here, is the x positive or negative? What's this x? Negative. Is the y positive or negative? Negative. This is where putting it on your axis helps your positives and negatives. So from this, I go do this again.
So you would have to switch in signs for the
No, because you're in quadrant 1. Everything in quadrant 1 is positive. Isn't your x positive, your y positive? Go by your grid. That's what's going to help you get the signs. Now, I do all this again, but I just bring the negative signs with me. Oh, my y had a negative. My x had a negative. These both had negatives, so this is positive. Negative divided by negative. This is a negative, this is a negative, this is a positive. Same triangle that we just flipped around. We just did a little rotation or a reflection through the origin, if you will, whatever you want to call it. If I look for this one, let's do this. 7 pi over 4. Where would I find 7 pi over 4? Negative 45, but give me, don't give me negative. Yeah, just say quadrant 4, this one. So is this still a 45-degree reference angle? Because 4 goes into 180 45 times. Same triangle, isn't it? So I'm just going to label my special triangle 1 over radical 2, 1 over radical 2, 1. So when I come down here, I say 1 over radical 2. So I look at it again. I say in quadrant 4, is my x-axis positive or negative? This axis right here, positive, right? In quadrant 4, is my y positive or negative? Oh, so this guy becomes a negative. Try to keep track of my negative signs. They get lost on my equal signs. And my radius is always, always positive. The radius is a measurement from the center of your circle to the edge of your circle. It always is positive. When I come down here, so I say, oh, my y value is negative, this guy's going to be a negative. My x value is positive, this guy's going to be a positive. My x is positive, but my y is negative, this guy's going to be a negative. I'm doing this part in green. I come here, oh, that was a negative, I swapped it. This was a positive, this was a negative. These don't change. They're not going to change. The only thing that changed was your plus and your minuses. Because that's where your x-axis and your y-axis landed.
What number were you on for that?
Nothing. I kind of did the first two together, but I kind of just blew up the 45-degree angle here. I just figured this is a good time to look at what your reference box does and what your circle being on an axis actually buys you. It tells you where your positives and negatives are. I find it easier to do this than to put on my triangle, oh, okay, this piece over here has to be negative, this piece over here has to be positive. So now every time I think x over r, I have to think, okay, this one's negative, negative over, this one's positive, positive over positive. This one's negative over positive. I hate doing it that way. I like bringing it back out. Because it does also get a little bit messy in there. So do we kind of get the feel of rotating this angle around? See why these special triangles are so important? 2 is the exact same as 1. It was this one. It was the exact same angle. It was that angle. Because it started here and went negative. Negative rotates clockwise. So the one before 8 is a 7. Or negative 315, which brings you all the way back to here. And that 45-degree angle is the reference angle.
I did both for like circle and I made like all the
Yep, and you can do that too. Yep, you can do that too. Whatever you get comfortable with, I tend to do this. And for anybody that doesn't get this, this really, really works well. To pull out your reference pieces, it is the same numerical number, but God bless you, but the positives and negatives change because of what quadrant it landed in. So is my x-axis positive? Is my x-axis negative? Is my y-axis positive? Is my y negative? Your radius will always, always be positive. Good? We're moving on, I know. What? Question? Because how many degrees in your circle? Yep, if you come around this way and you went 315 degrees, this is 360. So if 315 went here, your goal is to find out, oh, what's that angle there? So 360 minus 315. You only go up and down to the x-axis, never the y. You could never put a bow tie like this. It has to go like this. Otherwise, my chin can't fit into it. So whenever you do trig, picture me with a big red bow tie. I've got to wear this bow tie.
So that's made by the reciprocal line.
Using degrees. But using radians, take this number and divide it into 180. 4 goes into 180, 45. It's always going to be a 45-degree reference angle, no matter what quadrant you land in. Okay. All right, let's try another one. Let's do the 3's here. So I'm going to start like this. How many times does 3 go into 180? 60. So I've got a 60-degree angle. Let me make a 60-degree triangle. So how should I label this? Anybody have an idea? Opposite the 30 is what? 1. Opposite the 60 is? Radical 3. Opposite the 90 is? 2. Because this is the smallest angle, this is the largest angle, this is the one in between. So if I want to put this on a unit circle, what should I divide everybody by? 2. If you want it on a unit circle. I think this exercise was unit circle, but it always works out the same. Because otherwise, if I just say 2, I'll say radical 3 over 2. It'll all work out to be the same ratios. Okay, so now I got to figure out what quadrant I'm in. So because it's a 3, this is going to be a 3, this is going to be a 3. Something in front of my pi. This guy has to cancel out the pi, so what number has to be on top? 3. This guy is twice around, I have to double it. So what's this number? 6. Now, I always start right here, my positive x, and I rotate counterclockwise unless it's negative. So as I come across, here's my reference point, 3. 2 above, 4 below. Always the first one is your 1. What's the number before 6? 5. So what quadrant does my 2 pi over 3 end up in? Second quadrant. If this is 3, 1 less is 2. This is my reference angle right here. If I convert this to degrees so that you can see it. Oops, sorry. If I take this out, 60 times 2 is 120. If I come around 120 and this is 180, and this guy is 120, what's this reference angle? 180 minus 120. This is my 60 degrees. So I'm going to put what I labeled. Opposite my 60 was radical 3 over 2. Opposite my 30 was 1/2, and my radius 1. And now I say this. In quadrant 2, is my x positive or negative? Negative. Is my y positive or negative? Positive. I'm good to go. So I say, okay, sine y over r, because my radius is 1, it's my r, radical 3 over 2. If you wanted to label this point, it would be your x value, it would be your y value, because the point is an xy, which is what you see in a lot of books, and you probably saw that on your Regents. They love a unit circle question. My cosine, well, I can't say that because now you changed to common core, so. And my tangent is y over x. So I have to do radical 3 over 2 over negative 1 over 2. Remember, when you flip it, the 2's come out. If your denominators are both the same, just crunch it down to a fraction. Take the 2's out, because when you keep change flip, they're opposite each other. So when these denominators are the same, just crunch the fraction back down to radical 3 over 1 or just radical 3. And then you can find your reciprocals, right? Cosecant, flip this over. Secant, keep the same signs. Cotangent, okay. Good. All right, let's find where this guy is. Where is negative? Which way did the negatives rotate? Clockwise. So I'm coming here. I want to find 5. 5 is 1 before 6. So what quadrant is that going to put me in? First quadrant. I'm coming all the way around. I'm in the first quadrant. What's my reference angle? How many times does 6 go into 180? 3 go into 180? Sorry, 60. So it's the same triangle, isn't it? It's like I took this triangle and just reflect it through all my quadrants. So I label it the same way. 1/2, radical 3 over 2, 1. In this case, both the x and the y are positive. And then all of those answers would be the exact same, but they would be positives. They would be the exact same. They're the exact same triangle. You can always check it on your calculator. You can pick up your calculator and say, what is this? Even put it in radians, and you don't even have to convert it to degrees. You know how to put your mode into radians, right? Put your mode in radians and put that in. Sine of that angle, cosine of that angle. These are called exact values. These are your exact trig ratios. Yes? Because we're finding where does this angle exist. Let me convert this to degrees for a minute. You're not a radian lover, I can tell. 3 goes into 180 how many times? 60. What is 5 times 60? 300. So if I start this and I'm going clockwise, this is 0, 180, 360. So I'm going to go like this. I'm going to stop short of 360, right? How many degrees are here between 300 and 360? 60. So in radians, we can just do it because we're going to follow this pattern. And we could say, okay, it either can be 1 pi over 3. It can be 2 pi over 3. It could be 1 after this, 4 pi over 3. Or it could be 1 before 6, 5 pi over 3. In this case, we had to go in the opposite direction, so this brought us to negative 5 pi over 3. See it? Who said no? No? Okay. We're in 60s, so 1 pi over 3. We're using these as our points. 1 before this is 2 pi over 3. 1 after this is 4 pi over 3. One before this is 5 pi over 3.
Oh, so number 4, the angle is quadrant 4?
No, it was negative. If that was a positive, then it would absolutely be in quadrant 4. If the angle was this, only because we have to rotate this way, the opposite way. The opposite way. If we were rotating if we were rotating the positive way, yes, it would be in quadrant 4. But because we had to, yeah, but they kind of like switch around because you're negatives and positives. I can tell you guys didn't do a lot of coterminal angles. No. Okay. It's hard because I'm not really sure, and because it was the first year, neither were the teachers that were doing this. So it was not their fault because they didn't realize also that you needed the trig part for the other regions. So it was kind of like a jumbled in. So if we're taking a little extra time, that's what we have to do. All right, so let's find this now. This is good because this leaves us with what reference angle is this going to give me? How many times does 6 go into 180? 30. So this is going to leave me a 30-degree reference angle. So again, I'm going to make my triangle. Oh, it's the same triangle as before, just a different reference angle. So I'm 1, 2, radical 3. I'm going to do this without the unit circle. Is that okay? I'm going to, so that you guys see that it is the exact same thing. So I say, okay, here's my circle. Which direction am I rotating? Clockwise to the negatives. So as soon as I go 1 down, what quadrant will I be in? 4. Okay? Let's rename this for a second. My angle is negative. Okay, let's rename this. This would be 6 pi over 6. This would be 12 pi over 6, and then we start at the 0. So if I was going to make this a positive angle, what angle would be coterminal to this angle? In other words, what angle would start here and stop right here? 11 pi over 6. Very good. Because what's the 1 that's right before the 12? 11. What reference angle is this? What did we say? How many times does 6 go into 180? 30. I'm only going to be able to make 4 of these guys also. And yeah, I can kind of make another one here, but if I do that, then that's a 60 degree. What is 2 30s? 2 30s is a 60, right? I only need my 30-degree angles. So everybody only makes 4 sets of angles and this little bow tie. So right now I'm in this quadrant. So let's label it like this one, just for the heck of it. 1, 2, radical 3. This was where my 60 is. Okay. In this quadrant 4, is x positive or negative? Positive. Is y positive or negative? Negative. So now, I'm going to do the sine of negative pi over 6. It's y over r, negative 1 over 2. Isn't that the same as if I took that and divided everybody by 2? Right? Isn't that the same as my unit circle one? Cosine of negative pi over 6. So I'm taking my x, radical 3 over 2. Tangent of negative pi over 6. take my y value, -1, and I put it over my x value, radical 3. Isn't that the same as if I divided everybody by the radical 3, by the 2 to get there? Right? Now, if I call this angle 5 pi over 6, what quadrant is 5 pi over 6 in? Second, I'm coming all the way around. Here's my markers. So I'm coming all the way around. I'm going counterclockwise, my regular. I got to stop before the 6. That's where my 5 is. Right here, when I terminate right here, this is your terminal side. This is 5 pi over 6 from here to here. So 5 pi over 6. So this is still my 30-degree angle in here. Same triangle. So 1, 2, radical 3. The only difference here is this. They're all the same numbers, but in this quadrant, is x positive or negative? Is y positive or negative? Positive, and r is always positive. So all that changes is my positives and negatives. But the rest of the stuff fits right in. Feeling it a little bit better? A little bit. Okay, the last one, I'm going to divide 2 into 180. I got to know where my reference angle is. So 2 goes into 180 how many times? Oh, it's a quadrant angle. It's a quadrantal angle. So I got to go around pi over 3. I know I'm using this as my reference angle. I kind of have a 90 degree as a reference angle. But I've got 3 pi over 2. So I'm setting this up as 2 pi over 2. Keep the same denominator. 4 pi over 2. I'm going every 90, which is right at the quadrant. So here is my 1 pi over 2, my 2 pi over 2. Here is my 3 pi over 2. Write down your unit circle at the 0, -1. This is my x, this is my y, this is my c, this is my s.
All the other ones we just divided by the 80.
We did. We divided this into, we took 180 divided by 2, which gave me 90. So where do my 90s fall? On these guys. These are where my 90s fall. They're technically not a triangle. But you could, they're on the quadrants. But technically you could set it up as a triangle because this is also your radius. That's your y value and your radius. But it's not worth it to set that up. So we start like this. So the sine of 3 pi over 2. The sine is y over r. In this case, I'm on a unit circle. All I need is my y. What's my y value? -1. I'm on a unit circle. My cosine is x. What is my cosine? Oh, my tangent is y over x. So -1 over 0. Can I do that? Undefined. So there is no tangent to this. However, let's take the reciprocals. Cosecant. When I flip this guy over, it still gives me what? -1. When I flip this guy over, it's technically 0 over 1. When I flip it over, I am 1 over 0. I am undefined. And cotangent, well, I might have been undefined here, but if I flip this over, I'm 0 over -1, which is what? 0. Yes? Are we making a list? So I want you to kind of do exactly what we did today. I want you to get very, very comfortable with your special right triangles. Agree? And I want you to find all 6 exact trig functions the same way we did today for all of these angles. They all work off your special triangle. I cannot ask you to do an exact value of something that's not a special triangle or a quadrant. We don't have any other angles but these. So write these down and give me all